The existing ground shows, if you remember the cross section, I'll go back to this from last week. The plan view shows points described by the station and the offset. Remember this? That's what we're plotting, station offset, station offset. That's how we describe the points in this plane. In this plane, we describe everything by station elevation. And the last two pairs that go together are the offset, how far from center are you, and the elevation. So that's what we're plotting in the cross section. Okay? So when you're plotting this information, you see offset and you see elevation below. And you have a left and a right, and it's all laid out spatially relative to center. So right at the center line, that's the existing ground. 3.5 meters to the left, that's the elevation. 5.1 to the left, that's the elevation. 9.5 to the left, that's the elevation. These distances are all offsets. Distance from center, distance from center, distance from center. Okay? To plot this in AutoCAD, okay, this is the engineering discussion. To use AutoCAD to draw this, think of the top line as the x coordinate, right? The offset. The offset is in this direction, that's the x coordinate, and the elevation is in this direction, that's the y coordinate. So the top row is x, the bottom row is corresponding y. So this is the point 20.7, 107.11, x and y. The other thing you need to be mindful of is left and right. If 0 is in the middle, left, if we're looking into the board, right? If we're looking up chainage, the left side is your left hand, the right side is your right hand. Left is sometimes called negative. So if it doesn't say left, you might see negative. So this is the coordinate negative 20.5, 112.82. All the elevations are positive. Offsets are either plus or minus, right or left. Okay? So plot these points. Let me demonstrate a little bit. I'm not going to draw everything, but certainly I'll give you clues. Okay? So today I want to show you two things you need to pay attention to. The method. What did I do first? What did I do next? What did I do next? And so on. And then some AutoCAD techniques on how to draw these particular things. Okay? So it's a little bit of a demo, a little bit of a discussion. So if I wanted to draw this, the first point would be negative 20.5, 112.82. So if I go to AutoCAD, I'm going to draw a polyline. PL for polyline. I apologize for the small font down here. That's why I'm just going to give it to you orally. I'm just going to talk about what I'm doing. Okay? So polyline command. PL for polyline. And I'm going to type in that coordinate. So the coordinate is negative 20.5, 112.82. So negative 20.5, comma, 112 point, what was it? 112.2. 112.82. 112.82. Right? And it'll start drawing. Then type in the next coordinate. Just keep drawing. So then the next coordinate is negative 15.3, 111.33. So negative 15.3, comma, 111.33. Next one, 9.5, 110.53. Negative 9.5, 110.53. And if I zoom in here, you'll start to see the cross-section too. Okay, I'm going to stop there. That's the first part, right? So I drew 3. 1, 2, 3. Everybody see that? Understand the technique? I would draw it as a polyline. You could draw it as a series of lines, however you want to do it. And just leave it like that. Don't smooth it out. Don't fill it. Don't spline it. Just leave it as connect the dots with a bunch of straight lines. Okay? Now, through the magic of television, you know when you see a cooking show, they stuff the turkey and then they pull out one that's already cooked? Right? So I've got this turkey. So I've already drawn this. Let me bring it back to life. Existing ground. Right? So I drew the first 3 for you, and there's the rest of it. So each vertex is a coordinate. Offset versus elevation. And remember, left offsets are negative. Okay, so on this, even though it's not a negative shown, right? All of these, the left ones are negative, and the right ones are positive. Positive 0 is 0. Okay. So you can see the trend. It's 112, 111, 110, 107, 107, 107, and then it goes up a little bit, and then down, and then back up, which is exactly what's happening here. Okay. Now, for reference, I'm going to draw the center line. So I'm going to draw a line from 0, 0. I'm going to turn my ortho on, and I'm going to go straight up. So there's the line. These are positive, these are negative coordinates, right? This is the 0 offset. Okay, so if I ID that, you'll see the coordinate is x equals 0. Ignore z, right? I know it's a 3D space, but we're drawing it in 2D. Any questions about how you draw the existing ground? It's as simple as that, just a continuous line or polyline. Start on the left and go toward the right or vice versa. Do them in order and then they're all connected in the right way. The next thing to do is identify where the center line proposed elevation is. So if you go back to the design information, I want to know where 110.875 is. So I'm going to draw a line from 0, comma, 110.875. So there's the design elevation at the end of this line. So that's the crown of the road, right there. Okay? 0 offset, it's right in the center of the right of way, and it has an elevation. You want to ID the point, it'll give you the coordinate. 0, right on center, 110.875. Okay? I know the numbers are hard to see down here. I apologize for the font size. I don't think it'll let me, yeah, AutoCAD's good. Does it help that I describe what I'm saying? I know it's hard to see. Okay? Most of these techniques should be familiar. Like I know you're not CAD illiterate, right? We've done some of this, but it's a new application, a new reason to use these tools. So I go back to the design information and it tells me, I know that it's a tangent section, and I know that it's an RCU 90. So now I go to my cross sections. RCU, right? Whoops. RCU 90. RCU 90. So it's one of these. Okay, let's go back to the design information. The design hour volume is 475. Well, that's useful. So I can go back to the document. And I'm greater than 450, so the information I need is in this row right here. Everybody understand how I concluded? I'm here? I know the road classification, right? The page is labeled right here, RCU. RCU, I know it's 90 kilometers per hour, so it's one of these. And then I'm also given the design hour volume greater than 450. So all the information I need is in this highlighted blue row. Okay? Remember, there's 6 pages. 6 rural and 6 urban, and you're drawing one cross section. So of the first 12 pages, you only need to narrow it down to the one that you need. The rest of the pages for this one is irrelevant. Big fat hint, you're not doing an RCU for homework, right? We're doing one together as an example, just to outline 2 things, the methodology and the CAD techniques, okay? All right, so based on this, I know each lane is 3.7, and the shoulders are 1.5. I'm just gonna write these down here. 3.7, 1.5, and the rounding is 0.5, 0.5. These are the 3 main parts of the road. Remember, lanes, shoulders, and rounding. So let's establish those zones, okay? How many lanes do we have? Let's go back to the given information. It's a 2-lane road. So I go back to AutoCAD. I'm going to offset this center line. Offset, the lanes are 3.7. So 3.7, offset left and right. There's one lane, there's another. Remember, the width of the lane is horizontal. It has nothing to do with the crossfall of the road. Next, I want my shoulders. Offset each of those by 1.5. So there's the 1.5 shoulder, there's the 1.5 shoulder. And then I want my rounding, 0.5. So I'm going to offset.
The shoulder's 2.5.
Sorry, 2.5. Did I write it down now? 2.5, my apologies. Offset 2.5. This side and this side, and then finally the rounding, 0.5. So those are the 3 main parts of the road. Now, when you offset the rounding of 0.5 meter or 1 meter, the roundings are either 0.5 or 1. There's no other options, depending on the road classification, speed, design hour, volume, so it's either one of those 2 numbers. To draw what you need to draw, you need the center of the rounding. So if the rounding is 0.5, what's the offset to the middle? 0.25. So here's the middle of the rounding. I need this position. Okay? I'll probably not do anything with it other than extend to it, but you'll see what I mean. So you also need the center of the rounding. Now I need to draw the cross-section elements. So to do that, I look at a generic cross-section for crossfall. So I go back to this document. Okay? I might not be done with this page, but let's go on. So we looked at this last day briefly. If you're drawing cross-sections, here's the details of all the different layers. Right? So I know I'm looking at a rural section, and I know it's a tangent. So everything here applies. tells me the crossfall of the asphalt pavement, it tells me the shoulder crossfall, it tells me the subsurface layer crossfall, it tells me the subgrade crossfall. Okay? So I'm going to use this information. This is the generic piece of information you need for slopes, and together with the pavement structure that's required, you're going to use both of those pieces of information in combination. Okay? So if we go back to the section example, let's look at the different layers. 40, 50, 150, and 350. Okay? These are all in millimeters. You have to divide by 1,000 and draw everything in meters. Okay? The other thing you want to be mindful of is in AutoCAD, one AutoCAD unit represents 1 meter. Draw it like this. Okay? Not millimeters. Draw it in meters. We're civil people, not architects. Okay? So, 40, 50, 150, 350. This is a discussion we had the other day. Okay? I want to draw the depth. Actually, let me draw the cross slope first. Let me draw the surface. So if I go back to here, 2%, 6%. How do you draw those planes? Just like this. Watch. I'm going to draw a line. I'm going to turn my ortho on. So I'm going to go horizontal, 1 meter. And then I'm going to go vertical. 2% of 1 meter is 0.02. And then I'm going to close. This is the slope 2%. Right? 1 meter horizontal, 0.02 vertical. 2% of 1% is 1 meter is 0.02. So there's the slope you need for 2%. Take this, move it from this end point, and put it right where the design of the crown is. Remember this point? Right? I don't need this reference anymore. Extend it the full width of the lane. Right? I don't care how long this is. The width of the lane is exactly 3.7. This line's going to be a hair longer. Ignore that. Never measure on the 3D. Always horizontal or vertical. Okay? The plane for the shoulder is 6%. So I'm going to go horizontal 1, 0.06. Close. Whoops. 0.06. Close. There's 6%. 1 meter horizontal, 0.06 vertical, and there's my angle for 6%. Put it on here. Extend it the width of the shoulder, but if you remember, we go back to the detail on the first page. The plane of the shoulder goes to the middle of the rounding. So extend it to the shoulder and beyond to the middle of the rounding. That's why I established the center of the rounding. So I'm going to extend not to the shoulder, but all the way to the middle of the rounding. Okay. Everybody with me? Okay. I'm going to mirror this. It's exactly the same on the other side. Right? So this is 2%, this is 6% to the center of the round. Okay. Those are the 3 main parts of the road. The lanes, the shoulders, the rounding. Any questions so far? Okay. Now, we now need to establish, once we have those 3 things, we now need to establish the different layer depths. Okay? So, the depth of the layer is a vertical thing. And let me show you my example. I'm going to draw a line out here. I'm going to draw this line at a weird angle, right? There's the angle. If I tell you the thickness of the surface is 10 meters, your gut instinct is to offset. So I'm going to offset 10 meters. Whoops. I'm going to offset 10 meters. OF. Offset 10 meters. So I'm going to offset this by 10 meters. There it is. Okay? Now, that's 10 meters. That's not what we mean by depth. Okay? The thickness or the depth of the material is vertical. I'm going to make a copy of this straight down. Turn your ortho on and go straight down 10 meters. Different solution. Everybody see that? So if I draw a vertical line from here to here, and I draw a line from here perpendicular to here, these are both 10. And in civil engineering, the convention is vertical. When I talk about the thickness or the depth of something, I mean the vertical depth. Okay, so this is what you want to do. So again, your gut instinct is to use that offset tool. It's wrong. The only time you can use an offset is if the thing you're offsetting is flat. Then the offset and the vertical copy is exactly the same. Otherwise, it's different. And think about curved items. If I draw an arc, if I offset that by 10 meters, I actually get a different radius. If I copy it straight down, 10 meters, it's the same radius. This is what I mean when I say thickness. So on a vertical curve, that's what I mean, not this. Both of these dimensions are 10. This one is not how we do it. Okay? So you want to work in this industry, when you talk about thickness of material or depth of material, it's always vertical. plumb, straight down. Okay? It's a hard habit to break if you're not used to it. I've been doing it so long that I forget sometimes about the offset tool. Not that I don't use it, but in this particular application, it doesn't serve any purpose. Okay? Does everybody see the difference? So if I want those depths, if I go back to my design requirements, 40, 50, 150, 350. In meters, I'm going to make a copy of these two layers. And I know the shoulder has the same thickness. It says so right here. The shoulder is the same as the top, so 40 millimeters. So I'm going to copy these straight down 0.04, 40 millimeters in meters. So there's the thickness of the first top layer of asphalt. Then I'm going to copy the bottom one. And I'm going to go down 50, right? According to the design, I need 50 millimeters. So 0.05. 0.05. So there's the two layers of asphalt. Okay? Then I need the layer of the base and sub-base. So I've got 150 and 350. So I'm going to make a copy of the bottom of the asphalt, straight down to 0.15. And then I copy this straight down 0.35, I believe. 0.35. Okay? So there's the thickness of each material. Now, be careful. Don't forget to check this. I took my 2% and 6% plane, I copied it down for the first layer of asphalt, I copied it down for the next layer of asphalt, I copied it down for the interface between base and subbase, and then I copied it down to establish the subbase subgrade. Well, that's wrong. The 2 and 6% is true for all layers except the very bottom. The very bottom is at the bottom, it's going straight down in the center, right here. From here, go down 3% either side. So there's no more 2 and 6, it's just 3. Now, here's where it gets kind of funky. Students lose their minds, right? It's hard to see in this. If this is 2% and this is 3%, and I establish the depth here of 350, when we're moving this way, the layers are getting, the layer is actually getting thicker, agreed? It's 2% on top, 3% on the bottom. As you move away, it gets thicker. So when it comes to a construction estimate, right, the thickness times the width times the length of the road is an approximation. You'll always be a little bit under, because it's not a constant width. So when you get a pavement design, those depths apply right in the middle. As you move away from center, depending on the crossfall of the different layers, you may have thicker materials. Okay? So this layer is typically always thicker because of this kind of divergence of two slopes, right? 2% on top, 3 on the bottom. As you move away from center, it gets thicker, and that's understood. So the thickness, when it comes to the design, applies right at the center. After that, it gets fatter, right? Thicker. Everybody cool with that? Right? So when I establish my depth of pavement layers, it happens at the center. And then beyond that, then these slopes take over. We may get slightly thicker layers. So I have to establish 3%. So I've got the crown of the subgrade in the right spot, but the slopes are wrong. Go back to CAD. So that elevation's good, but it's the wrong slope. So now I'm going to get rid of this. I'm going to draw a line from here. Cross 1. 3% is 0.03. Close it. There's the angle I'm looking for. I'm going to delete that. I can get rid of this now. Extend to here. Mirror. And there's my 3%. Notice the distance from here to here is 0.35. From here to here is 0.387, a little bit thicker. This is 2%, this is 3%. Okay? Everybody with me so far? Now, the next thing to do is look at each side. Is it going to be a cut or a fill? You almost have to guess so that you know what to do next. Okay. It looks like I'm going to probably have a fill on both sides. I'm not sure. Maybe a cut here. I really can't tell. If we go back to the detail, let's just look at the cross section, make sure we can do it right. Whatever the slope is, if it's a fill slope, then the 6% and the 3% come to meet the slope of a fill. If it's a cut, then this would be called a side slope, right? And then we have a back slope going up. Whatever this is, you need to establish that slope. Okay? So I have to assume it's going to be a cut or a fill. I have to kind of guess and see what happens. It's this point. If this is above the original ground, it's a fill. If this point is below the original ground, then it's going to be a cut. Okay, so let's take a look at that. So let's go back to the design requirements, so back to here, and then go back to the RCU. Right, and remember 90, greater than 450, we're looking at this. If it's a fill slope, use 6 to 1. If it's a cut slope, the side slope is also 6 to 1. So I'm going to come down from the center of the rounding, 6 to 1 on both sides, and see what happens. Let's go back to CAD. So I'm going to draw a line from the center of the rounding. From here, I'm going to go over. How do you draw 6 to 1? You go horizontal 6, and you go vertical 1, and then you close that, and there's a 6 to 1 slope. And then, remember the property is 40 meters wide, 40 meter right of way, so I'm going to offset, just for reference, 20 meters from either side of center. There's my right of way. If I extend this, I don't touch the ground. So a 6 to 1 is going to be too flat. And it looks like it wants to be a fill. So let me try, instead of a 6 to 1, let me try a 4 to 1. So I'm going to draw a line from the same point. I'm going to go 4 and down 1, and then close that and extend that. That's still no good. Okay, let me try something steeper. 3 to 1. 3, 1, close, extend. Gonna hit one of these. Oh, that'll work. And what do I have to do? I have to make sure offset 1 meter. This is the no touch zone. You have to touch the ground before you enter this zone. You want to tie back into the original ground before you get to that 1 meter from the edge of the property line. So a 3 to 1 will work. If I want to maximize it, I can just draw a line from the rounding all the way to exactly that point. That's going to be flatter than 3 to 1. What's the slope of this line? I'm going to draw a line from here. I'm going to go straight up 1. I'm going to go across, and I'm going to trim it. This length to 1 is the slope of that line, right? It's actually 3.444 to 1. Typically, we use a standard number. Sometimes we use a standard position for where the toe is. It's up to you. I'm going to use 3 to 1. If I use 3 to 1, I might need a guide rail. I might not. I don't know, right? If you go back to the design requirements, if you have no guide rail, you must use 6 to 1. If you're going steeper than 6 to 1, I'm using 3 to 1, I might need a guide rail. I'd have to analyze this. Okay. For now, just draw it without the guide rail. We'll analyze it later. Probably not today, maybe later this week. It might not come into play on your side. The other side, again, 6 to 1 on both sides without a guide rail. So let me try. Let's see what's happening on this side. I'm going to draw a line from this end point. I'm going to go 6. I'm going to go down 1. I'm going to close it for these. And there's my line. So how do I know whether it's a cut or a fill? I'm going to extend to the slope this layer and this layer. Whoops. Yeah, this layer. I forgot to copy. I need my 6%, right? I already screwed up myself. Let's go back to here. Forgot to make a copy of this. Right, it's 6%. I forgot to copy this for the top of the sub-base material. Let's go back. A copy of the 6% plane. This end point to here. There's the top. And then you extend both of those to the slope. At this point here, you can get rid of the rounding. But you need that line there. This is all asphalt in here. This is just, I'll draw a line across here. These are just dimension lines. That's what it's going to look like finally, right? Actually, that's wrong. The asphalt ends here. There's your line. Across here, same thing. There's my asphalt layer. There's my asphalt layer again here. From here to here, I'm going to draw a line. This is all the same. From here to here, I'm going to draw a line. And from here to here, I'm going to draw a line. And trim this off here. I don't need this anymore. I'm going to trim these. You'll be able to see better without these dimension lines. Whoops. Extend all the way to here. This plane. Copy of this 6% plane to here. Extend that to the slope. And so on. So when you trim out these lines, able to see the road. So there's the 2 layers of asphalt. They end right here. That's the wing. Then there's a paved shoulder. Then there's the rounding between here and here, right? Look at the dimension lines. If you bring these back down, right, there's your rounding zone. So the shoulder ends there, but the plane of the shoulder extends across at 6% to the middle of the rounding. So now you can clearly see this point is above the ground. This is a fill slope. Just extend it till you touch the ground, right? And then we're going to ignore the ditch beyond that. And we'll just tie it. On this side, you'll see this point is below the ground. This is going to be a cut. So how deep should we go down before we start coming up? Well, back to the standard. Whoops, go back to page 1. We need to have from that point at least vertically a ½ meter to the bottom before we start coming up. So from that point there, I'm going to extend the 6:1 so that it's vertically 0.5 below this point here. How do you do that? You're going to draw a line from this end point, straight down 0.5, and go across. Extend to that depth. Whoops, extend to that depth. So there's a vertical depth of 0.5. And then from there, to go back to the original ground, this slope, the back slope is always 2:1, regardless of standard. Let's go look at RCU, right? RCU, the 91, it's always 2:1 to go back. So go back to the drawing. From that point, I'm going to go horizontal 2, vertical 1, close, that's the angle. And I'm going to extend until I hit the original ground. So there's my ditch. Offset 1 meter. Bit of a violation there. Everybody see that? All right? I'm supposed to touch the original ground, but within a meter of the edge of the actual right of way. So that's a bit of a violation. And this is the kind of stuff you're going to deal with. Okay? So what can you do now? Well, theoretically, you might put a little wall there, but it's not practical. This you might be able to get away with. Or if you draw from the invert to this intersection here, it's going to be a little steeper than 2:1. Okay? So strictly speaking, it doesn't work. What do you do to fix this? You want to raise the cross section so that it ties in sooner, right? We could do this. I could move this, right, the entire cross section. I could take my entire design and raise it until I know it works. But when you do that, you're changing the centerline elevation, which means you're actually changing the design of the profile. If you raise this elevation, you're changing the profile design. Okay? So this is a little bit of back and forth. Right? I'm going to accept that, close enough. I'm at least within the right of way. Yeah, I violated that mirror, but that 1 meter no touch zone, but I'll keep it for now. Okay? So these are the kind of things you run into. The fact that it's close is because when I do my original profile design, remember proposed versus existing, I try and match the existing as close as possible. If I'm close to existing in the center line, then I'm close to existing on the edges of the right of way as well. Okay, that's why it's pretty close. It's not perfect, but it's close enough. So just to review very quickly, always draw the existing ground first. Find the crown of the road elevation, the design. Okay? How do you get that? From the profile. For homework, I'm going to give it to you. Draw all your different layer thicknesses based on the crossfalls of the typical section. Get all your widths from the section detail, whatever page applies. And then draw your either side or fill slopes and extend the layers until they touch. If this point's underground, you have to continue down to the ditch and then back up. This is called a cut, side, and back slope. There's always 2 slopes. On the other side, it's a fill. That point where the subgrade meets the slope. The point where the subgrade meets the slope is the one that's key. If that's above the original ground, then you take that slope and you touch the ground and you're done. That's a fill slope. So those are the options, cut or fill. You can almost guess. For homework, you're going to have one of each as well. I want you to practice more. Okay. I'm not going to do it now, but remember this is not 6:1, so we need to analyze this. If I need a guide rail, I have to make this ½ meter wider. I'd have to extend the plane of the shoulder. So instead of just a rounding of whatever, I need an extra ½ meter. What am I talking about? Let's go back to the cross section. If I had a guide rail, I would need an extra ½ meter on the 6% plane between the shoulder and the rounding. I need a little bit of room. Sorry. But that's beyond today's discussion. To draw it without a guide rail, and then we'll analyze whether you should put one in there. Now, if you manage to draw it with the no guide rail slope, if I was able to complete this with a 6-to-1 slope, I'd be done. I wouldn't have to analyze anything. But because I compromised the no guide rail condition slope, now I need to check, do I or do I not need a guide rail? And we'll see the factors that determine that analysis. Okay, let's go back to CAD. So this is the cross section, proposed versus existing. When it comes to the, I'm not going to throw those away, I'm just going to move them out of the way. Right? You can't draw this cross section without the information that we looked at, right? You need to know how wide the lane is, you need to know how wide the shoulder is, you need to know how wide the rounding is. You need to know the slope of the pavement, the main lane of the road, 2%. You need to know the slope of the shoulder. You need to know the slope of the subgrade. You need to know the pavement thickness. All the numbers, whether it be a depth, a width, or a slope, are required to draw this. Everybody agree? Without those numbers, I can't draw this. Now, if I've drawn it perfectly with those values, if you print this, it's perfect, right? Everybody agree this is good to go? I can hand this in? I've completed the exercise. If you print this and hand it in, you get 0. The exercise requires that you label all the lengths, the widths, the slopes, the depths, whatever number you use. So this is the criteria. If you use the number to draw it, that number should be annotated on the drawing. Okay? And examples of what you're drawing are in the last few pages of the document. Let me show you. So you want to know kind of an example of what's in, what's out? Let's go back to this document. If you look at the last few pages of the entire document, you'll see typical sections with all the information, right? So if I had to draw this, there's the lane width, there's the shoulder width, there's the rounding, there's the crossfall in the shoulder, there's the crossfall for the lanes. How thick are the pavements? There's a note right here. I know the layer of all the different, I know the thickness of each layer. All the numbers that were used to draw the cross section are annotated on the drawing. Okay? Think of it this way. If you needed that information to draw it, then the contractor needs the same information to build it. So it must be on the drawing. Because you're not supposed to scale drawings, remember? Picture is there for reference. It's the data, the numbers, the text that's important. Okay? So if you use a number, make sure that's annotated on the drawing. So there's an example of a couple of cross sections, just to use as a guide. Now, it doesn't have to be in color. I don't care about hatching. Just draw the line work and dimension everything, right? Label the slopes, label the widths, label everything that's important. Okay? Label it. Tell me what it is, right? In this case, it's probably, the name of the section will be the station, 4 plus 650, right? Don't just draw a section. Well, where is it? 4 plus 650. What's the pavement thickness, and so on. Okay? So this is all the information you need to show. So there's a lot of great examples at the back of the booklet in terms of drafting standard, what to show, right? Here's a super elevated section. Here's a tangent section. If you go back one more page, there's a couple more examples. Super elevated urban. Here's a urban section with a turning lane. And here's one with a divided with a median in the middle and so on. Okay? So everything you need to draw it was annotated on the drawing. And if you needed it to draw it, then the contractor needs it to build it. So put it on the drawing. If you draw it perfectly, and there is no text on your drawing when you hand it in, you're going to get 0. I'm looking for the numbers. Yeah, I'm going to make sure you drew it properly. Make sure everything looks right in terms of angles and widths and so on, right? It has to be drawn accurately to scale. It has to be annotated, completely annotated for any value you use to draw. Okay, so that's the example. For homework, you're going to get something very similar. A list of criteria. I'm going to tell you the road classification, the number of lanes. Is it tangent or super elevated? The pavement structure. I'm going to give you the design for the center of the pavement. I'm going to give you the existing ground cross-section data and so on. So you have to draw it. Draw it in AutoCAD, plot it to PDF, upload the PDF. That's the last question on the next assignment. Okay? So the methodology, I hope, is clear. Existing, proposed center, widths, depths, and then analyze each side. Draw your fill or cut. You're going to have one of each, I promise. And then annotate it. Annotate it with everything you need. Now, to plot this, if you want to make note about plotting, because you drew everything at 1 to 1 meter, to plot this, right, once it's all annotated, let me just get rid of this. If I go to plot, the device you should use is right here, DWG to PDF. It's the third one from the bottom, so DWG to PDF. The paper size you want is 24 by 36, standard engineering size, 2 by 3 foot, or 24 by 36. So let me put some notes on the board. So the plot device is DWG to PDF. So the device is DWG to PDF. And the file extension is PC3. PC3. This is third from bottom, typically. Okay, if you're looking for it, it's near the bottom of the list. That's the device. The next thing you want to look at is paper size. Use a 24-inch by 36-inch, which is typically a D size page. D size. Sorry about the 24 by 36-inch D size architectural size page. The next thing you want to look at is the plot area. Use just a window. So use a window. You could use extents, but use a window. So you grab the whole thing, make sure everything's visible, including all the text and the dimensions and so on. And once you do that, for scale, you have to do this in millimeters. It can't be fit. We want to plot it 1 to 100. So to plot it 1 to 100, there's some funny business going on. So plot scale. Plotting scale. You have to. If you use 1 AutoCAD unit equals 1 meter, then the plotting scale has to be divided by 1,000. So if I want to plot it 1 to 1,000, I plot it 1 to 1. If I want to plot it 1 to 100, then the plotting scale is 1 to 0.1. Divided by 1,000. Okay? The original software was designed for architects. They used to use millimeters instead of meters. So 1 to 1,000 is 1 to 1,000. We're doing meters, so we have to divide the scale. So if I want to draw on paper, 1 to 1,000, my plotting scale has to be 1 to 1, divided by 1,000. Okay? So if I want 100, I actually want 1 to 100, divided by 1,000, it's 1 to 0.1. This is your plotting scale, so that you can get 1 to 100 on paper. So here we go. 0.1. And then if you want to center the plot, you can. And if you preview it, it should look like this. And I know the paper is bigger than it needs to be, but that should show you. Paper size is probably bigger than it needs to be, but if it had a title block and all this other stuff, it would be fine. I don't want a title block. Plot it from model space. Paper space, model space, viewports, no. Keep it simple. Just draw the thing and print it from model space. No title blocks, none of that. Okay? We'll keep it very simple. It's about the design. I'm not too concerned about the drafting. Title block, your name, the job, and engineer stamp and all that. No, I just want to draw. I want to see the design. Okay? Again, color doesn't matter. You can do it all in black and white. You might want to have a line type for existing ground, dashed like that, but it doesn't have to be in color. Don't waste your time hatching. Okay? Does that give you a better sense of what I'm expecting? So for homework, you're going to get a similar list of information, and you've got to navigate your way through the document and use the various data. Some of it is specific to the road classification. Some of it's generic, like the different layer slopes and so on. Okay? Any questions about the method? Time we done? 1:30? Okay, so again, like I said, if you just walked in and saw the final product, you're not quite sure how that was born, right? Think about the method. Existing, proposed center, proposed standards, right? Standard stuff, lane, shoulder rounding, depth of material, get your crossballs going, and then it starts to become obvious whether it's going to be a cut or a fill. So the next thing you need to do is to determine the end area of cut and fill. When you're performing an earthworks exercise, remember, we don't build the finished ground. We build the subgrade. I'm going to make a copy of this just for discussion off to the side. I'm going to take this and put it over here. Get rid of this. So there's my design. What am I building with the native earth? Well, I'm going to erase these layers. These are the construction layers, the asphalt, right? The granular. None of this has to do with earthworks. I'm going to trim this. This is called the subgrade. That's the shape of the ground before you bring in your granular material, your base, subbase, sorry, your subbase, your base, and then your two asphalt layers, right? So you have to build this out of the native material first. Okay? So, first thing you do on a construction job is strip all the topsoil. So if this is the existing ground and you have the geotechnical report, you can get a sense of what the top layer from your boreholes is, right? How much organic, how much topsoil you have. So you can actually lower that vertically for the topsoil depth. Right? So let's assume we have a foot. So I'm going to make a copy of this straight down, 0.3. Right? So if you take away all that information, that's your starting condition. Right? If you take away all that topsoil, that's your starting condition. Strip. And then this is your pre-grade, right? Without the construction materials. So this is what you have to build. Now, I'm not going to bother you with the topsoil depth, right? I'm going to assume this is already stripped. Keep it simple. Okay? So it's already stripped, and this is the pre-grade. Remember, do not include your construction material. How much cut, how much fill? Well, if the existing ground is above the proposed, I have to remove this material. Everybody see that? And if the existing ground is below the design, I have to fill. I have to bring material in. I have to raise the ground to match the subgrade. So there's two areas here in this particular example. There's some cut here. It's mostly fill. Everybody see that? To get the end areas, I turn my O snaps to intersection, and I'm going to draw the line. Polyline from here to here to here to here to here to here and to here. That's the area, right? Because it's a polyline, if I list it, it gives me the length, the perimeter, and the area. So there's the end area, 8.543 square meters. Everybody see that? So that's one method. Trace it with a polyline. Here's a better way. If your drafting is clean, if that's truly a closed figure, you can use a command called boundary, BO for boundary. You can pick a point, and if it's truly closed, it'll draw that polyline for you. And now you can list that, and it tells you the square meter end. This is total cut, this is total fill. Everybody see that? The boundary command is a very basic AutoCAD command. I don't think you learned that in DEA 001. And even if they had, it might not have made any sense to you until you see a reason for using it, which is what I've shown you right there. Because the boundary command is pretty powerful. If you want to trace it with a polyline, go right ahead. But it wouldn't be as efficient. So those areas, total end area of cut, total end area of fill, must also be annotated on the drawing. Cut equals so many square meters, fill equals so many square meters. Put those two numbers on your drawing as well. Okay? Can't do that until that's an analysis thing. You can't do that until the design's done. So draw everything and then get these two end areas. Okay? Now, if there's some cut here and then fill in the middle and some more cut here, if you have two separate areas that represent cut, add them together. Total cut, total fill. Okay? Any questions about that? Total cut, total fill. All right. And then all the annotation that we talked about, right? I don't need to see the polyline that you drew, right? Just do it off to the side, get the number, put the text on the drawing. And that's good. Okay. Remember not to include your construction material. Right? That's not native earth. Right? It's not native material. You shape your subgrade and then you bring your construction materials in to go to the finished ground. So you design it to finish, but then you build it to the subgrade first, and then you bring in your construction materials. Any questions so far? Okay. So if you have some pretty decent CAD skills, this doesn't take long, right? The exercise is really looking up all the information. It's going to be on more than one page. You have to kind of navigate the document. There's some pages we haven't discussed yet, but I've done enough for you to get started on the assignment. I'll probably cover the rest by the end of this week or early next week. Okay? So this cross section, so the assignment's going to be handed out on Thursday this week. I want it back next Thursday. The drawing part of the assignment, I'm going to give you an extra couple of days. I'll accept them because you're uploading them to Blackboard. It's a PDF that you're uploading as an assignment. I'll give you an extra couple of days. So there's some hand calcs you have to do. Those are next Thursday. The drawing, maybe Friday or Saturday. Yeah, I'll give you a couple extra days for the drawing. It's kind of your first time to shine with AutoCAD, right? You've learned AutoCAD, But now you're gonna use it for a course that's not about AutoCAD, right? This is highways. So use that tool to do this, right? You take an English course, you use Word to do engineering reports. So now you're gonna use CAD to do a design in highways. Okay? Things are starting to cross over quite a bit. Any questions about the drafting of the cross-section? Okay? Very similar. The data changes, not this. I'm gonna give you something similar to this. Okay? Once you have the end areas, you can then calculate cut-fill total volume for a project. Okay? And that's what this handout's about. Let's do this together, because there's going to be something similar to do on the assignment. So this is the volume calculation.